Continuing into our physics lessons, we're going to take a look at some simple basic acceleration. Acceleration, just like speed, is a rate, but this time acceleration is the rate at which something speeds up or it slows down. So when you got a car and you're at the red light and you hit the gas, you go from 0 to 60, that's an acceleration. Whereas when you're driving down the road with your cruise control on, that's velocity. Velocity is constant. Acceleration is exponential in its change. So acceleration will be changing the speed of something over time. So acceleration is the rate at which speed changes. The rate at which speed changes. And since this is a rate, that means there's going to be a formula. So our formula is acceleration equals delta V over T. A is acceleration. V is velocity. And T is time. Now acceleration we measured in meters per second squared. Since it's a rate over time, meters per second, it's meters per second squared. It can also be miles per hour a second, or even kilometers per hour per second. But the main one you'll see is typically meters per second squared. Your velocity will be measured in meters per second, could be miles per hour, could be kilometers per hour, the standard units that we saw in the last lesson, but you'll typically see it in meters per second. Time, once again, we measured in seconds, minutes, or even hours. Now in our formula we got this delta V. Delta means change in, the change in velocity. So if you don't remember how to calculate a change in or a delta, in this case it's delta V equals velocity final minus velocity initial. So the final velocity minus the initial velocity will give us the change in that velocity, which we divide by our time to get acceleration. You may also see negative accelerations. If you see a negative acceleration, that means you are slowing down. You're braking, you're coming to a stop, but your speed is decreasing. So that means positive accelerations mean you are speeding up or increasing your speed. Just a little food for thought for your notes, because you will eventually run into those. So now that we got that out of the way, let's look at some basic problems, see if we can't figure this stuff out. So our first problem says, what is the acceleration of an object that goes from 10 meters per second to 30 meters per second in 5 seconds? So let's pick out our information. So what is the acceleration? So I'm looking for A. To find acceleration, I need a change in velocity and a duration, or a time that it happens in. So my change in velocity, I go from 10 meters a second to 30 meters a second. So delta V equals velocity final minus velocity initial. So that's going to be my final velocity is 30 minus my initial velocity of 10. So my change in velocity is 20 meters a second. And this occurred in 5 seconds. 5 seconds is my time. Now we can set up our formula. Acceleration equals change in velocity over time. If you prefer a T-chart version, then that is delta V over A and T. Your choice on which one you do here. I'll use the T-chart version. So to solve for acceleration, let's plug in. So I set up my t-chart. A is what I'm looking for. That's x. Delta V is 20. And time is 5. So 20 divided by 5 gives me 4. But as always, we need units. And the units of acceleration is a distance per time per time. In this case, we were meters per second per second. So meters per second is written as meters per second squared. And there is our answer. Let's look at another one. What is the velocity of an object that accelerates for 10 seconds at 3 meters per second per second? What is the velocity? So I'm looking for that change in velocity. We know we need acceleration and we need time. So 10 seconds is a time. 10 seconds. 3 meters per second is an acceleration. So that's 3 meters per second squared. We set up our formula. Delta V over A and T. Delta V is what I'm looking for. That's x. A is 3 meters per second squared. T is 10. To solve for this x variable, we multiply everything on bottom. So x is 3 times 10, which is 30. 30 what? Our acceleration was in meters per second per second. Our time was in seconds. So this unit of time cancels out one of these units of time, leaves me with meters per second. And there is our new velocity, or our change in velocity. So let's look at one last problem. If an object accelerates at 2 meters per second squared and it increases its speed from 0 to 45 meters per second, how much time was spent accelerating? Alright, so we are looking for time. I need acceleration and I need a velocity, a change in velocity. My acceleration is meters per second squared, and that's 2. My speed changes from 0 to 45. So change in speed is final minus the initial. 45 is my final. 0 is my initial. So my change in speed is 45. And that's going to be meters per second. Now we can set up our formula. Delta V over A and T. Change in velocity is 45. Acceleration is 2. Time is x. So to solve for x, we do 45 divided by 2, and that gives us 22.5. But what is our unit? Our rates were in seconds, so this time will be in seconds. And there is our answer. So acceleration isn't too dissimilar from velocity in terms of solving problems. So we have a 3 variable formula for right now. It does get a little bit more complicated later down, but for right this second, it's simple. So in order to find velocity, multiply acceleration and time. If you want to find acceleration, divide velocity by time. And if you're looking for time, divide velocity by acceleration. Always make sure your units are consistent. If your time is in seconds, then your speed and acceleration needs to be in seconds. If your velocity is in meters per second, then your acceleration needs to be in meters per second per second. So make sure you pay attention to your unit. Make sure you pay attention to your mathematical operations. And I hope this video helps. And as always, good luck on your tests.